Okay, and now for the very last question on this worksheet, we want to practice coming up with guesses for the particular solutions, and we'll leave it there. I'm not going to actually go ahead and solve for those undetermined coefficients. So in all of these cases, whether it's A, B, C, D, E, or F, or if I even had more, what's the first thing that we need to do? We need to find the homogeneous solution because we may have resonance. So let's take the characteristic equation corresponding to the left side of the differential equation, which would be r squared minus 8r plus 12 equals 0. And then we can solve this, so we can factor this into r minus 6 and r minus 2. So we see we have two real roots, r is equal to 6 and r is equal to 2. So my homogeneous solution would be y is equal to a, let me use a different letter, c1 e to the 6t plus c2 e to the 2t. And so let's just quickly run down each of these and identify whether we would have resonance or not. And I'm just going to put a check mark or an X. So in A, there's definitely no resonance. Our homogeneous solution was real, was exponential things. The forcing function here is a trig function. So there's not going to be any resonance on that one. Is there going to be any resonance on B? There's going to be no resonance on B because this forcing function, although we have the 6t here, it also has the sign of 2t. And so since these differ by a sign, then we're not going to have any resonance. For the tangent one, we are also not going to have any resonance with that one. And then let's take a look at in D. We are actually going to have some resonance because we have an e to the 2t over here, and we have an e to the 2t over here. In E, we're not going to have any resonance, and in F, because we've got the cosine piece, we're not going to have any resonance. So there's only one where we have resonance. So let's start with that one in D. So in D, my guess for the particular solution would be something like x of p is going to equal some general linear thing, at plus b times exponential e to the 2t. But since there's resonance, we would need to multiply by another power of t. So in other words, my guess here would be a times t squared plus b times t e to the 2t. Okay, so we did have resonance for that one. And now let's backtrack up to part A. So in A, we did not have any resonance. So my guess would be some constant times the sine of 2t plus some other constant times the cosine of 2t. In B, again, no resonance here. So now my guess would be y of p is going to be some constant e to the 6t sine of 2t plus some other constant e to the 6t cosine of 2t. In part C, we never did anything with the tangent, so this is not going to work. If you're curious about how to do that, you can check out the next section in the textbook, but this is not material that's required for you. So I would never ask you to come up with a guess for the tangent. We haven't handled that just yet. We haven't done power functions where the power is negative either. So we'll learn some other methods to handle these situations, but method of undetermined coefficients is not going to work on part E either. On part F, we can definitely handle this. We don't have to worry about resonance. And so for this one, my guess would be some general linear expression at plus b, since 6t is a power function where the power is 1. that's a b here, times e to the 5t cosine of 3t, and then I would need to add to that, again, some general linear thing, ct plus t times e to the 5t times the sine of 3t. And that would be our guess for part F. So definitely practice problems like this one to get ready for the exam. And if you have any questions, please pop in to office hours, which is when our usual class time is on Zoom. Okay?